start with pi 6 because I know I have my pi 6 memorized. I know that the sine of pi 6, I know pi 6 is a 30-degree angle. So I have anything with a pi 6 memorized, that the sine is going to be that 1/2 opposite of our hypotenuse. And then the cosine is going to be a √3/2. And then that tangent would be the opposite over the adjacent. So that's that 1/√3. So I've got this guy down for my pi 6. Now I have to think about, pause and think about, well, wait a second. This isn't in quadrant 1, though. This is 7 pi 6. And I know that 6 pi 6 would be over here. This guy here is 6 pi 6. So 7 pi 6 lands me in quadrant 3. Well, in quadrant 3, if I think through my sines, a super trig class, in quadrant 3, only tangent's positive. So now I'm going to go back and I'm going to say, well, that has to be negative and that has to be negative. The reason why they're negative is because this is y over r, and in quadrant 3, y is negative. You go down, and this is x over r, and in quadrant 3, x is negative because you go left. So you can kind of think that through. This is negative over negative. That's why you get a positive. And now some of you have been rationalizing, and that's okay by me. I think that's just because you're more used to that from last year, and that's fine as well. Okay, so I've got the pi 6, the 30-degree memorized. I know that it's 1/2 √3/2 and 1/√3, which is really going to help me next chapter. And then, oops, throwing things. And then I'm going to think of it, well, let's go from the other angle. Let's go from the pi thirds. Let's go from the 60-degree angle. So from the pi thirds, if I go from the 60-degree angle, now opposite over hypotenuse would be this guy here, the √3/2, and adjacent over hypotenuse would be 1/2. And then opposite over adjacent is the reciprocal of this, so that would be just a plain old √3. Now I think about my sines. Well, I'm in quadrant 1 here, so I know that they're all positive. Okay, I can go to a 45-degree angle. I have that triangle in my head, so I'm picturing the 45-degree angle. I know anything in terms of pi fourths. Anything in pi fourths is going to be that 1/√2, or √2/2 if you want to rationalize. Again, 1/√2. And then tangent is going to be 1 because the opposite and the adjacent have the same length. But now, where am I at? Am I in quadrant 1, 2, 3, 4? Because that has a big factor in my signs being positive or negative. So pi fourths, well, I know 8 pi fourths would be pointing to the right. So 7 pi fourths would be quadrant 4. Only cosine is positive in quadrant 4. So I'm pop a negative and a negative. Okay, so if you know your pi thirds, you know your pi fourths, you know your pi sixths, like that would be the idea. Have those memorized. And then from there, you can take a moment and pause and say, well, which quadrant are we in, positive or negative? See, look, I knew my pi thirds, and therefore I know my 2 pi thirds. Like these are going to be the same numbers, √3/2, 1/2, and √3. This is quadrant 2 now. In quadrant 2, only sine is positive. Same thing here, like these are all connected. See those? So that's why we should be able to do this fairly quickly. This is almost 6 pi thirds, so it's almost all the way around. So we're in quadrant 4, so only cosine is positive there. And I've got a quadrantal right here, 3 pi/2. So my quadrantals, I have that picture memorized, that quadrantal picture. I know 3 pi/2 points down, so sine would be a -1, cosine would be a 0. Tangent, a lot of you are writing an n, which is okay as long as you understand that n means undefined. So the idea is to just kind of have these memorized, or at least know like the basic pi thirds, pi fourths, pi sixths, and then from there be able to figure out what quadrant you're in, if they're positive or negative. Honestly, it will ease up a lot of trouble for you in our next chapter. Okay, so let's look at quiz B. If you just flip your page over, you had quiz B next. Quiz B. Now, I'm giving you your 20 out of 20, whether you have them all right, all wrong, 3 done, or all of them done. It doesn't matter to me. You're showing me effort. But do take a moment here and see. Solutions are undefined. There you go. Yes, good question. Go way forward here. Okay, if you already did both of these, then just kind of cover up what you did, and you can make yourself another little box over here. Okay, if you only did one of them, then use the other box. I'm going to give you 3 minutes on the clock, so without peeking. So cover up your work, without peeking. You ready at home? Here we go, everybody. 3 minutes on the clock. Try it. Go for it. Go. Click a few buttons. Here we go. This one. That one. Okay. So the question now is, are they correct? You got your pluses and minuses. Let's talk law of sines now. Before class, I asked Mrs. Naraki. She's like, oh, yeah, they've seen law of sines. In fact, some of you have seen law of sines in geometry and in honors algebra too. But, you know, not everybody had honors geometry, so I'm not going to say you've had it 2 years, but you've at least had it 1 year. So this hopefully will serve as a nice review for law of sines today. Okay, here we go. Law of sines. So to do the law of sines, that's our learning target today. I actually want to go back to using some SOHCAHTOA. So first thing I'm going to do, let me just draw a big old oblique triangle. Now an oblique triangle has nothing special about it. It doesn't have right angles. It just has 3 sides that are not the same, 3 angles that are not the same. We use the law of sines on oblique triangles. There's nothing special about this triangle. Okay, so I'm going to label this triangle. I'm going to call it capital A, capital B, capital C. We name angles by capital letters. This is triangle ABC. And when I'm labeling a triangle, across from angle A is always side A. And so we do that with a lowercase letter. So the sides are always lowercase letters. So across from angle B is little side B. Across from big C, capital C, is a lowercase c. That's how we always set up our oblique triangles from geometry. So this triangle has a height. And as soon as I draw this height in here, H, I'll call it H. Well, now I have a little right triangle on the left side and a little right triangle on the right side. So I could use some SOHCAHTOA in order to figure some things out about that height. So let me use some SOHCAHTOA. So on the little left side here, let's see, I would have this, we'll color it in purple. So this purple triangle here, if I did SOHCAHTOA, I could say the sine of angle A, sine of angle A is opposite over hypotenuse, so that would be H over B. That's for the purple triangle. And then let's go with some green. How about it? So on the green triangle on the right-hand side, so this triangle here, I could also use SOHCAHTOA to say the sine of angle B is opposite over hypotenuse, that'd be H over A. Now notice these equations, they both have H in them. Let's do some algebraic manipulation here. If I multiply both sides here by the B, I can get the H alone. And let me multiply both sides here by the A, and I'll get the H alone. So for the purple triangle, we could say B times the sine of A equals H. And in green here, I can say A times the sine of B equals H. Well, look, if they both equal H, then you could set those equal to each other, right? So see how they both are equal to H. So that means that this guy and this guy are going to be equal to each other. B times the sine of A is the same thing as A times the sine of B, since they were both equal to H. Where am I going with this? Are you like, what's happening here? Well, all I did is I did SOHCAHTOA here, SOHCAHTOA here. But what I did is I just derived for you the law of sines. This thing is the law of sines. Now, we don't usually write it like that. I would kind of uncross multiply. I'll show you what I mean by that. If I move the sine of A over here to the denominator and the sine of B over here to the denominator, we get the law of sines. So here it is. It says if you take a side A and you divide it by the sine of the angle across from it, which is A, you're going to get the same ratio as if you did the side of B divided by the sine of the angle across from side B, which is called B. This is the law of sines. And we could also extend that to C, by the way. I just didn't extend it in my proof here to C, but it also is the same thing as side C over the sine of the angle across from side C, which we call capital C. This guy is called my law of sines. I'm going to write LOS a lot today, so I don't have to write law of sines over and over and over again. Law of sines. Okay, so I don't know, is this ringing a bell at all from last year? This when you do a side, you divide by the sine of the angle across from that side, it's all proportional. okay? Now this is for any triangle. It doesn't have to be a right triangle. In fact, I actually kind of want to write that up here. So for any triangle, see, SOHCAHTOA is only for right triangles, so law of sines is actually way more powerful. So for any triangle, we're going to use the law of sines. So again, I'm going to write use LOS for any scenario where I have a side and the angle opposite that side. Let me give you those two scenarios. So one of them would look like this. If I had like this side and this angle, and then maybe another angle like this guy, we call that angle, angle, side. Now I just jump back to geometry for you. Okay, if you're given the scenario where you have an angle, another angle, and then a side, you can use the law of sines because look, you could set up that proportion. Or sometimes you're going to be given that angle, side angle scenario. Let me show you that one that looks like this. It would have to have the side in between the angles. That's called angle, side angle. That's another scenario where we use the law of sines. Angle, side angle, and that's because it's really, really easy for me to find, this is the side, it's really easy for me to find that angle there. So don't answer, just hang on, think about it. And everybody in the chat, this is up to you. A question for you in the chat. Show me you're still with me. If I know two angles of a triangle, how come it's really easy to find the third angle? All right, you guys read it, go for it. And because this diagram is kind of funky, I actually prefer to draw it a little bit bigger so I can actually see a little bit more clearly what's happening. So they told me that L was 1,550 feet. So I've got that, and L is the distance between here and here. They gave me this angle was 15 degrees. Now they did give me this angle on the outside was 25 degrees. And that's helpful because if I know the angle on the outside, then I also know the angle right next to it on the inside. These are called supplementary angles. All this lovely geometry coming back your way. If this is 25, then that angle next to it will be 155. So I'm thinking, oh, look, they gave me angle, side, angle. And if I see that angle, side, angle scenario, I'm thinking, oh, I'm going to use the law of sine. So this is kind of what popped into my brain. Angle, side, angle. The side is in between the two angles. Let's use the law of sines. So we're going to set it up. Now, I do have to quickly find this angle here, and I'm going to do that by the advice that came through the chat there. 180 minus those two angles. So 180 minus, it's 180 minus 155 minus 15. Oh, that's a tiny little 10-degree angle. This is all I need, guys. I need an angle and the side across from it. So when I have that for any triangle, doesn't have to be a right triangle, I can set up my law of sines, which says the length of the side divided by the sine of the angle equals the length of the side. Well, let's see. They wanted me to tell the distance from A to B. So they wanted me to say what this side is here. So I'm going to go with the length of the side, x, over the sine of the angle across from x was 15. So the sine of 15. At this point, I've got my proportion, and I can just cross multiply to solve. Now, somebody in the chat, maybe not this class period, last class period, or first period, I should say, they asked, is it okay if you do the sine of the angle over the side opposite it? So if you did it like flip this, absolutely, it's a proportion. So if you were used to doing sine of 10 over 1,550 equals the sine of 15 over x, you get the same thing because we're going to cross multiply. I don't know what you learned last year. If you put the angle on the top, sine of the angle on the top, and the length of the side on the bottom, it doesn't matter at all. So let's cross multiply. Now you're going to need your calculator. You're going to need your calculator on degree mode because look at what happens. I get 1,550 times the sine of 15 equals x times the sine of 10. I'll divide both sides by that sine of 10. So all at once on my calculator, I'm going to type in 1,550 times the sine of 15 divided by the sine of 10. Okay, check that out. Start a new document. Don't want to save it. I'm going to use control division. That's like my favorite thing to do on this calculator, control division to stack my fraction. And then I can type in 1550. By the way, I'm checking that I'm in degree mode. Always want to check. 1,550 times the sine. Well, here's my trig button here. Here's my trig button. So I'm going to use that trig button next to the number 7. Not the inverse sign. We talked about that the other day. I think somebody was asking about the inverses. That's for solving for angles. So we're going to just do the plain sine of 15, and we're going to divide by sine of 10. Da-da-da-da. Now, if they wanted more decimals, I would highlight it and hit enter, and it's going to give me more decimals in case they specify needing more angles or needing more decimals, I should say. The chat is quiet at home, you guys. You feeling okay? Go ahead and read that second one then. Try it. Read that second one. The reason why it takes more than one step is because we're trying to find the height, and the height is not a part of the oblique triangle. The height is a part of the little right triangle on the left side and the right triangle on the right side, but they certainly did not give me enough information to use SOHCAHTOA on the right triangle on the left or the right triangle on the right. So I'm saying to you is like, I'm going to write over here, step 2. Step 2 was going to involve finding that height. And you can use, it doesn't matter. You want to use the triangle on the right side or you want to use the triangle on the left side. So step 2 is going to be involving finding the height. But look, they didn't give me enough information because the only thing they told me about that little triangle on the right-hand side here that I took out is that angle's 50. So I'm like, oh boy, I better back up and do something else first. And the something else first, I'm going to call that step 1. That is looking at that oblique triangle and figuring out what missing information would help me then to fill in this triangle. So some of these are 2-steppers. Oh, interesting comment came in the chat. Oh, I like that comment. I'm going to adjust that in just a moment. Let me get started with my oblique triangle. Nothing special about it. But I do know that this guy is 30, and I do know that this guy is 50, and they told me that this one was 1,200 feet. So step 1, I'm looking at angle, side, angle again, which makes my brain say, oh, we definitely should use the law of sines. Angle, side, angle, let's use the law of sines. Now, it doesn't matter. Do you want to find the piece on the left side? Do you want to find that side on the right side? I'm going to go with the side on the right side, but I actually really like the comment that came into the chat, so I'm only going to do this because this is what I did when I wrote my key. So I'm going to find that x, because when I find that x, it's going to be that same missing side over here. So law of sines says the side 1,200 over the sine of the angle opposite it. Well, the angle across from it I don't yet know, but it's really easy to find. Just 180 minus 30 minus 50. That's going to be 100 degrees. Equals, and then it would be x over the sine of 30. So I'll do some cross multiplying. And go ahead and get that number on your calculator because we're going to use that over here. So what is that? 1,200 times the sine of 30 equals x times the sine of 100. So I've got to divide. Okay, so whatever 1,200 times the sine of 30 all over the sine of 100 is going to be that missing piece x. Now, when you get that x, let's see, that x is, I got about 609.255 ... What I want to warn you about, look at caution, warning, 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 flashing here. Do not round this, okay? Don't round this, because if you just said it's 609.2 or 0.3 or 609.26 and you use that here, then you're going to be off a little bit when you write your final answer. So keep that number on your calculator. Keep that number on your calculator. Know that that number is the same as this number here, 609.255, ... Okay, actually, you guys in the chat here, tell me something in the chat. You ready? I want to know, since it's the right triangle, I'm going to use SOHCAHTOA. Should I use sine, cosine, or tangent? Tell me in the chat first. Sine, cosine, or tangent? What are we using here? I would say if I'm going to use the 50 degrees, then I'm going to use the sine. Opposite over hypotenuse. So I'm going with sine was my vote. So I have the sine of 50 equals opposite, which is h, over hypotenuse. And this is where I said, please don't round. Actually use this number. Because on your calculator, what you could do is take that exact number, that's 609.255, and then just say times the sine of 50. And I think, let's see, I got 466.72 feet when I did that. Before I let you go, let's read this third one and set it up. Go for it. Let's see, we have a tree. Oh gosh, I'm such an artist. Look at this. Ooh, okay. So we have a tree. I want to know the height of the tree, so I'm going to call that h. We don't know it. Now the height is perpendicular to the ground. And we're standing like way back here. We're looking up at angle of elevation, they said. So the angle of elevation is 40 degrees. So from the horizontal, that angle is 40 degrees. Now we step 40 feet closer, and we're going to at some point look up again, and then you'd have to raise your head higher. Now be careful, that angle of elevation is this angle here, that'd be 60 degrees. And this was, I think, 40 feet. So before you go, I just want you to see it. This is going to be another double stepper. And the reason is because, yeah, we've got this little SOHCAHTOA right triangle here. We have that right triangle, but we don't know enough information about the right triangle. So watch for that when you're practicing your e-text tonight. You don't know enough information about this right triangle that I highlighted in purple there. So instead, let's start with this triangle here. That green one, because we know that this angle right here is 120. And so in the green triangle, we have angle, side angle. So you can use the law of sines. So this is kind of like my step one. So I would use the law of sines to figure out this part here, which is x. And then as soon as I had that, then I could set up SOHCAHTOA on my purple triangle down there. So this would be step two, and that would be SOHCAHTOA. All right, so don't think that tonight, like you're just gonna jump right in. Law of sines is gonna give you the answer. There could be some double steppers.